Greetings and welcome to my new calculus channel. My name is John Gabriel. Today I would like to talk about one proposition in particular, and I'm going to say that propositions 21 through to 26, or I think it's 27 if I'm not mistaken. No, it's 26. Propositions 1 through to 26. There's only one interesting proposition out of all of those, and that's proposition 22, which I'm about to show you why that is really the only interesting proposition out of all these propositions. So in other words, there are, let's see, 6 propositions, and they're all based around proposition 22, which states that you can construct a triangle from any 3 given sides, provided any 2 of those sides are longer than the third or the remaining side. So the actual construction is not important, but what is important is the fact that this proposition goes all the way back to what was derived in the prologue, in my prologue to the elements of Euclid, which means that the first requirement really satisfies all of this, because if any of the 2 lines are joined, right, on that straight line, like so, then you don't have a triangle anymore. So it's irrelevant really to talk about the object that is a triangle. Okay, so if they're equal to the longest line, then you don't have a triangle. So the actual construction is trivial and not the point of this proposition. But what does it say exactly? It says that a triangle cannot be a triangle unless it consists of a path that is composed of the shortest distances between any 3 distinct locations. So let's look at the construction, which is trivial. And the way to see the truth of this proposition is to take the 3 line segments, starting with the largest and going down to the smallest, and then ensuring that 4 plus 3 is greater than 5, or that if you place these alongside, they'll be greater than this largest line segment. So you start off by creating that line segment, which can be done using a circle. And so you have the radius, which is 5. Then you take the second largest line segment and just position it at one of the ends, like so. Okay. Well, it doesn't have to be exact, like so. And then take the remaining one. Okay, take the remaining one and position it at the other end. Okay, like so. And finally, you can make arcs to where the third line will meet, so it will be approximately there. Okay, so over there you'll be able to join the 3 points, and that will form the triangle that is equal to these 3 lines. So it's as simple as that. It's not a hard proposition, and that's all that's really worth noting in this series of propositions from 21 to 26. And in some aspect, these are all just a focus or a different perspective of the first requirement, really, which is a straight line, and from which you derive the circle, and from which you derive the triangle. Okay, so you don't just have, I don't know if Euclid saw these things, but I'm pretty sure he did. I don't imagine that he could have missed these things. I'm just perplexed, and I don't really have the answer why he took the approach he did in book 1, proving these things in a very obfuscated, long, drawn-out way. But in any case, now you know how to do them, and that's all I have for today. My name is John Gabriel. This is a new calculus channel. Till next time, goodbye.